Good morning, guys. Happy Monday. Welcome to today's lesson, May 18th, Factoring Completely. We're really just going to look at some review questions, different types of factoring, questions where we can factor more than one time. But let's get right into it with the do now. All right, first one, x squared minus 81. Is this an example of GCF factoring? Is there something we can divide both x squared and 81 by? The answer is no. Would this be dots, a difference of two perfect squares? It sure would be, because x squared is a perfect square and 81 is a perfect square. And what that means, guys, there's something you can multiply by itself to get x squared and to get 81. So what times itself gives you x squared? That would just be x, right? X times x is x squared. What times itself, or what's the square root of 81? That would be 9. And remember, with dots, one of your sets of parentheses has addition and the other has subtraction. And you're done. It's good to check and just make sure, can I factor this a little bit more? Is there another example of dots? Is there AM or GCF? All right, there is not. So we're done. But we're definitely going to make sure that we're checking. All right, x cubed plus 4x squared plus 3x plus 12. What type of factoring will we have here? Check for a GCF. Can we divide all four terms by the same value? We cannot. Since there's four terms, we'll be thinking about factoring by grouping. So group the first two terms and group the second two terms and find a GCF for each. So what would the GCF be for x cubed plus 4x squared? The answer would be x squared. So we're going to divide both of these terms in the first group by x squared. And since this is true GCF factoring, guys, x squared goes out front of the parentheses. So x cubed divided by x squared is x. 4x squared divided by x squared is 4, so plus 4. Our GCF for the next set, our next group, 3x plus 12, what could we divide both those by? That would be 3. Divide each of these by 3. So plus 3. And then open your parentheses. 3x divided by 3 is x. 12 divided by 3 is 4. All right, and you can see we have that common expression there. So one of your final sets of parentheses has the GCFs, x squared plus 3, and then the next one has that common expression of x plus 4. And now you're done. And you're done because nothing can get factored more. X squared plus 3. No GCF, no dots, no AM, right? AM and AC are only for trinomials. All right, so we're done. Next, 3x squared plus 11x plus 6. Is there a GCF? The answer is no. It's a trinomial now, right? 3 terms. So is it AC or is it AM? The answer would be AC because of this number right here, that A value. The number in front of x squared is bigger than 1, right? 3. So we're going to use AC factoring. And what that means is we start by multiplying A times C, 3 times 6, which is 18. And now we need to know what are the two integers that multiply to 18 and add to the B term, which is the number in front of x, which is 11. So what multiplies to 18 and adds to 11? That would be 9 and 2. So open up your two parentheses. They're both positive, so plus 9 and plus 2. And now we don't put x in front of each of these, we put the A value with x. So 3x plus 9 and 3x plus 2. Now with AC we're not done. Remember, we have to divide out if there's an opportunity. So is there a GCF for either set of parentheses? Either or both. All right, for 3x plus 2 you can't divide anything out. But for 3x plus 9 you definitely can. What could we divide by here? It would be 3. And remember, this is sort of this AC factoring. You never learn this, all right, prior to now. This is not true GCF factoring. This is like a trick, so the 3 does not come out front like your normal GCF factoring. So it's just saying, what's the new set of parentheses? We do not do that. Put the 3 in front. Alright, so 3x divided by 3 is x. 9 divided by 3 is 3, so plus 3. We got x plus 3, and 3x plus 2 we can't break down anymore, and now we're done. Alright, so factoring completely, very simply put, after you factor a polynomial, there are times one or more of the factors can still be broken down. If you look at x squared minus 81, we factored this in the do now, right? We got x plus 9 and x minus 9. Now with x to the 4th minus 81, this is another example of factoring using dots, because x to the 4th, just like 81 and x squared before, x to the 4th is a perfect square. Because if you take the square root of that, you get x squared. What does that mean? That means x squared times itself, right, is going to give you x to the 4th. Remember, you add the exponents when you're multiplying. So what times itself gives you x to the 4th? That would be x squared. And what times itself gives you 81? 9. 1 positive, 1 negative. If you stopped here, if you were factoring, you would be wrong, because you can technically factor more. This right here, that's another example of dots, because it's 2 perfect squares separated by a subtraction symbol. The first set of parentheses has 2 perfect squares with an addition sign in front, so that would be no good in terms of factoring more. So we'll keep that first set of parentheses, x squared plus 9. And for that next set of parentheses, that can be broken up into 2. What times itself gives you x squared? That will be x, right? X times x is x squared. What times itself gives you 9? Times itself. That would be 3. 1 addition sign, 1 subtraction sign. Now you're done. So this is an example of factoring completely. Okay, now x squared minus 2x minus 15. Check for GCF always first. There's no GCF. This is a classic example of AM factoring, because the value in front of x squared is 1. And there's 3 terms, right? Trinomial, AM. So what multiplies to negative 15 and adds to negative 2? What are the 2 numbers that multiply to negative 15 and add to negative 2? Now they have to be different signs. Why is that? Because they're multiplying to a negative. Whenever it's multiplying to a negative, the signs have to be different. Alright, so hopefully you came up with it, but it would be negative 5 and positive 3. And now you can always think about checking that, guys. Negative 5, right, times 3. Does that give me negative 15? Sure does. And when I add them together, do I get the b term of negative 2? You sure do. So you check it out, good to go. Alright, basic AM factoring. Can't factor anything anymore. But let's look at one that's a little more challenging. We have 2x cubed minus 4x squared minus 30x. Is there a GCF? We'll always check for it first. The answer is yes here, guys. What could you divide all those terms by? So let's look at the numbers in front first. So between 2, negative 4, negative 30, what can you divide all those numbers by? You can divide them all by 2. Now all of your x values, x cubed, x squared, and x. Guys, they all have at least an x to the first power in common, so that's included in your GCF. So your GCF here would be 2x. Each of these terms, divide them out by 2x. This is true GCF factoring, so 2x goes out front of your parentheses. 2x cubed divided by 2x, what would that give you? That would be x squared. Negative 4x squared divided by 2x would be negative 2x. Negative 30x divided by 2x would be negative 15. Now are we done? Look in your parentheses here, guys. Can we factor that more? Look familiar? Right, we just factored that exact expression. X squared minus 2x minus 15. This is just your standard AM factoring. So it's just factoring completely. You could just factor one more time. That's all that is. So you still have the 2x out front. And now what did that expression, that trinomial, what did that just break down to? Right, it was x minus 5 and x plus 3. Now you're done. One extra step. So this is GCF and AM factoring. Alright, one more. Now there was a mistake on the worksheet. Make sure you do not use plus 16 here. Alright, we're going to use minus 16. So your start here is x cubed plus 4x squared minus 4x minus 16. So is there a GCF? There's no GCF, so what we're going to do, we're going to break it down. Into two groups because we have 4 terms in total to start with. Alright, so your GCF for the first group, x cubed plus 4x squared, what do they both have in common? Right, they both have x, and what to the highest exponent, what do they at least both have? It would be x to the second power. So we can divide each term by x squared. X squared goes out front of your parentheses. X cubed divided by x squared is x. 4x squared divided by x squared would just be 4, so plus 4. Now your GCF for the next set, negative 4x minus 16. What's very valuable here, guys, that third term being negative, that's typically your indicator. Once you get to this second set of parentheses, and you'll talk more about this when you get to Algebra 2, but once you get to that second set of parentheses, usually that third term is kind of like a trigger for, are we going to divide out a positive for the GCF, or are we going to divide out a negative? All right, because that will, you really, remember with grouping, you need what's in parentheses, the x plus 4 here, you need that x plus 4 to show up again. All right, so in this instance, you're going to divide out a negative. So what could we divide both those numbers by? Think about 4 and 16. You could divide those both by what? You could divide them both by 2, but that's not the greatest. All right, we need the biggest number that can divide into both. All right, it would be 4. And remember, we're making it negative. And another reason you would make it negative, guys, both of these terms are negative. All right, so you can definitely divide out a negative. All right, remember, that third term is sort of your indicator. So divide both these by negative 4. Your GCF is negative, so minus 4 now. Open your parentheses. Negative 4x divided by negative 4. It's just x. And now negative 16 divided by negative 4 is positive 4. So we did end up with x plus 4 in both sets of parentheses. If we divided out a positive 4, we would have ended up with different parentheses, and then grouping gets all messed up. Alright, so your GCFs get a set of parentheses, x squared minus 4, and your common expression of x plus 4 gets a set of parentheses. So that's factoring by grouping. Now hopefully you're thinking, we're not done. That first set of parentheses can be broken down, right? X squared minus 4 is an example of dots. What times itself gives you x squared? That would be x. What times itself gives you 4? That would be 2. Remember, with dots we have one addition, one subtraction, and also don't forget about x plus 4 hanging out over here. Can't be factored more, but that still comes along. Alright, now you're done. So factoring completely, just factoring more than once, breaking down an expression as much as you possibly can. Alright, so what I'm going to do, I'll post your Delta Math today. That'll be due, like always, on Thursday at 8 o'clock. If you have questions, please ask them, message me and remind. And that's it. Have a wonderful rest of your day, and I will see you mañana.